Sorry. I was just kidding, Lath. You're good. The midterm exam and final exam will be optional. Okay, so the dean said that was completely okay, which is awesome because that benefits you. Rather than having to know everything for the final, we could just parse it out, break it up into each individual not sections, but each individual week for the quizzes. The midterm, again, same thing, optional. The reason I say optional is some people want to take it. I mean, some people might want to take it. I don't know of anyone that wants to, but if you do want to take it, by all means, you can, whatever the status quo was, whatever the previous setup of the class was, then you can do that. Just make sure you email me so I can set it up with you, and we have to set up a time. The final probably takes about 2 hours versus the quizzes that take less than an hour, less than a half hour in some cases. So just to kind of put that in perspective. And the final and the midterm would be timed, where I don't really time the quizzes, but the midterm and final would have to be timed just because some people will take forever if I gave them an unlimited amount of time. Quiz retakes 6:29 from 9 a.m. and 11 a.m. 9 a.m. is for quiz 1, 11 a.m. is for quiz 2. Make sure you email me if you want to do that, and then I'll add you to the Google Meet link. If you don't email me, then I will not add you to the Google Meet link, and you will not be able to take those. So make sure you email me. This week's live I'm sorry, first I'll stop. Is there any questions on 1 and 2? The first 2 things that I wrote here for the changes. Just want to make sure everyone's on board with this. Also, to save me grading and to save you work, I'm going to make it where if you miss a part of a quiz, like say you missed for your quiz, you got number 1 all right, but you just messed up the area of a polar region, you can just redo the area of a polar region part rather than the entire quiz. I didn't write that in here, but I will. And again, it's a win-win because I grade less things and you can take less things. So I think that's pretty nice. This week's live, are there any other questions for 1 and 2?
Yeah, is the midterm and the quiz retakes, are those one and the same things, or are those 2 different things?
Well, the midterm is optional, so it's completely separate.
Okay.
Yeah. I'm basically, and I'll show you a calendar in a little bit just so this makes more sense. But the midterm week is just going to be replaced by one mini lesson. Well, not one mini lesson, but one section that we're covering, or subsection, I should say. And then the retakes will also be that week. So it's basically like we buy back a week. It saves everyone time so you can spread out the learning rather than chunking everything at once. So that's, and again, I'll show you a calendar in a little bit because actually, let's just do it now. Why not just do the calendar now? All right, calendar. All right, so today, here, let's blow this up so you can actually see it. Let's do the week view. Nope, I don't like that. All right, so you did the quiz 2 yesterday. There was 3 different times. Here's all the sections that we're covering today. And then if you do, like someone's doing a quiz makeup today, like later on. So if you ever want to do that, I can set up an individual time with you if I'm actually available. Tomorrow is going to be office hours because I moved 513. 513 was originally here. Actually, I think it was here. It doesn't matter. I moved it to a separate week. Now there's no quizzes this week. So this is a no quiz week. There's no quiz next week, but you can make up quiz 2 or 1. I don't know why it just says 2 here, but really, if you do want to make up one of the quizzes, I add you to this calendar invite. So you just have to email me. There's also office hours here. And if you do want to take the midterm, that's why it's here. I'll write this so no one gets confused. It would be that day, the 30th. Actually, I don't even know the time for that because I still have that lesson. But I don't know. I'll figure that out. I doubt anyone's going to want to take the midterm. But if you do, again, email me so I can set up a time with you individually. I'm assuming that a lot of people are interested in doing that because why would you be? If you are taking the midterm, it's going to be 232, 234, all of 4.1. So 4.1, 4.2, 4.3, 4.4. I'm sorry, 414, 415. All of these, all the 4.3, all this whole section here, and then all of these 3 here. So it's going to be a huge test. It's going to be like a regular midterm where if you were in a regular class. So I would advise not doing it, in my opinion, but that's my thought on that. And then the quiz 3 is moved to this week. So now this is June. I'm in July here. The 6th, the quiz 3 would be here. Quiz 3 is going to be all of 5.1. So all of the 3 things we're covering today, and then 5.513, which is covered next week, is going to be on quiz 3. 513 is the most complicated, probably the most complicated subsection of the entire class. So that's why I'm giving it 1 whole day. So we can just do a deep dive in that, and that it'll be more clear. Someone just messaged, I think. Let's see what it says. So what are the benefits of taking the midterm final? To me, there are no benefits. It's just that some people go, well, I thought there was going to be a midterm. How can you just change it on us? So then I was just saying, fine, then you can do it. To me, there's no benefit. So like, why would you want to have everything lumped together? If that makes sense. It's just so if someone complains, to be honest with you. I just don't want anyone to think I'm being unfair. Hey, I wanted to take the final. Okay, fine, then you can take it. That's kind of what it is. I'm really weird about fairness. So hopefully that helps, Kelsey. All right. Oh wait, calendar. Sorry, I'm rushing all over the place here. Okay, so yeah, and then office hours this day, and then and since we bought back an extra 2 weeks, then these are all office hours days now. So now we can actually just meet once a week. I don't know if you remember before, this is how it was, and then I broke up 6.3 was all over the place. So now I shifted everything. So now only your lessons, your live lessons that are optional, you don't have to actually be at this live session, obviously, but they're only going to be on Tuesdays, and then Wednesdays are office hours. Again, if you want to meet with me, usually do half-hour sessions. I don't do usually more than that. They're not going to ever replace a lesson. So if you're ever like, oh, can you go over the lesson that you went over on Tuesday? There's a video for that. You don't need me to go over for 2 hours. Office hours are for clarification or like working things out together. It's not a full lesson. And it'll be like, you should have some kind of understanding. Let's just sharpen that understanding rather than a full lesson. So hopefully that makes sense. And then again, quiz 4 is going to be based on these 3 things, where before it was going to be 6.1 and 6.2. So everything is just parsed out way more. 6.3 is one of the harder sections because it involves a lot of memorizing. If anyone's taken Calc 2 before, you might remember the convergence testing. But what I did, and I'm still working on this, probably going to work with a student on this too, just to make sure it's student friendly. But I'm making let's do this. I'm making a flow chart. So when you actually are determining convergence, you can just follow this. And this is what I have so far, but I'm going to make it even better because I've already added new things to it. So you'll actually be able to have an open note. Like you'll be allowed to use this during that last quiz. And then we'll go over that in more detail later. And then you can also make up all of the quizzes at the end here each separate day. So like, see 3, 4, 5, and 6. So you can still have one. It's one last shot at the very end to make those quizzes up at the end. And this would have been the final exam week, right? But since we're getting rid of it, it's almost like a final. But you can pick and choose which ones you want to do. Like say you got an A in quiz 3, then don't redo it, but maybe fix quiz 4. So again, trying to be as flexible as possible, offer lots of chances to make up grades. And offering a lot of office hour individual help if you want that as well. And then some people are talking about like meeting on the weekends. I can meet on Sundays, some Sundays, but again, just email me and let me know what times and stuff like that, and we'll figure it out from there. Questions on the way this is set up. And I'm sorry I'm throwing this a lot at you at once. So just, to me, I think it's just important, so. Okay, so the third one then, this week's live lesson, again, we're just covering the 3 things. This is the 4th one, this 513. I'm moving it to next week just because it is one of the harder sections. We get to focus on it for 1 full day, and then you have a full week before the next quiz on that. So the quiz still won't be until the Monday after that week. So I feel like I might confuse people. So again, just the quiz 3 is after 513. So now you have 2 weeks to learn all the stuff we're going over today, and 513. And if you want, learn 513 on your own, maybe on like the weekend or something. And then when we go meet in class, you can at least have some kind of understanding of it if you kind of learned a little bit of it, from videos and stuff on the website. Always good to prepare, obviously. All right. And then it says, since we got rid of the midterm and final, there's extra days we can use that will not have to, so we won't have to meet twice a week. So all live lessons will take place on Tuesday. I already said that. And then quizzes will still be on Mondays, just like before. Okay. So it shouldn't be a big shift, and everything is a change to your benefit, in my opinion. Does anybody think it's not? Is there anyone that thinks that something's unfair? And if you don't want to speak up now, that's fine. Just email me or something like that. Just because I don't want to make people think that I'm like trying to screw them over or anything like that. Obviously, I wouldn't want to do that. So, all right. Well, If you do, just email me. I obviously don't want to be unfair on this. All right, so Unit 5, applications of integration. And if you remember, Unit 4 was all about integration. So this unit is all about applying that integration to make integration do certain things. Namely, the fact that integration can be used to find this area. Remember, we were talking about one of the things with calculus was why it was invented was to figure out the area of a weird shape. Okay, this is not a circle or a square or rectangle. It's a weird shape. So how can you find the area of it? Well, you can use integration. But integration is based on the accumulation of little bits. Like we went over in the last section, you're adding up infinitesimally many rectangles that are infinitely thin. But that accumulation, you're adding up little bits of something, is you can apply that to other things. And that's basically what it says here. This area is based on the accumulation of infinitely many rectangles that have a width approaching 0. Other calculations can be made using the accumulation that integration is based on. So it's all based on adding up little bits, bit at a time, to find other calculations, not just area. Okay, this is just going to be a sneak preview. You don't need to write any of this down. When I start writing on the whiteboard, that's kind of an indication that you should probably write that down. And I'll try to remind you, but you don't need to write any of this down. I just want your brains right now just to frame your mind around the fact that you're adding up little bits to find the area. You can use that to add up little bits to find other things. Okay. So 511 is the area between graphs of functions. And this is basically again, you don't have to write this down. This is just a sneak preview of what we're going to be covering today. But the area between graphs of functions is usually you're just finding the area underneath a curve, underneath the graph of a function, but now we're finding between. And to find the area between, you just use this formula right here where you subtract whatever's on top from whatever's on the bottom. Or really it should be whatever's furthest from the x-axis. So f is further from the x-axis here. So it's whatever's on the top minus whatever's on the bottom. Make sure you know that formula. That's basically what that's doing. We'll go into more detail about where that equation comes from. All right, 512 is the average value of a function. And in this case, what you're essentially doing is, oh, hold on, let me go back to this. What you're doing here is the same thing as what you were doing to find this area. You're just subtracting off another area. So that's how that's related to integration. This one, the average value of a function, is related on integration in the following way. Imagine adding up all of these y values. So say this y value is 1 and this is 2. Just imagine adding, there's infinitely many points here, but imagine adding up all those values together and then dividing by how many values there are. Okay, well, there's infinitely many, but if you use this equation, it actually will break it down for you. So this is finding the average value of all of these y values here. Okay, so whatever these values are, we don't know, but if you average them out, it ends up being some value, and this is what helps you find it. Okay, it'll make more sense when we start writing stuff down, but just for now, just know you're finding the average y value. So all these y values are something, they average out to some value here. All right, 513 is all about volumes. This is the one that we're saving for the next class, and you're about to see why, because it's very complicated. Okay, you usually can find the area of something, just like imagine this is a graph and you're finding the area underneath, but imagine rotating it around the x-axis, and it forms a weird shape. I don't know, it's like a cone kind of shape, but you don't really know. There's not really a name for this shape. It's defined by an integral, but you're basically adding up all of the areas in 3 dimension. Then you're doing this with the y axis. So you're rotating around the x-axis, rotating around the y-axis here. And then eventually we're going to be doing things where you, this is called cross-sectional volumes. Basically a cross-section is just a slice. So you're adding up infinitesimally many slices here. As you can see, there's only 4 here, but if you add more, now imagine adding infinitely many. So you're adding up the areas of each one of these slices, and you can do it with a triangle. This was squares. This is triangles, as you can see. Imagine infinitely many, filling in all those gaps there. And then the last one is half circles. Forms kind of a weird shape, but you can add up all those areas across here. You're adding them up using the integral to figure out the volume. Okay, this looks like a simple equation, but it does get more complicated. This was covered in Calc 1 in other colleges. If you took Calc 1 in high school, this was probably covered in there as well. But Wabanzi does cover this. So if you've seen this before, that's just the way Wabanzi does it. But again, we're saving this for next week. Normally I would have my students do this, but we're doing this online, so we don't need to worry about it. But like say you had a function y equals x squared, and you just cut a bunch of shapes out. Like what would the volume be if you imagine infinitely many for each of these? We're not going to do that, but it's like still a good visual to see kind of what this looks like. But yeah, again, next week we'll cover that. And then the last thing, that we're going to cover today is 514, arc length. With arc length, so look at this picture up here in the upper left. Arc length is the distance. If you just walked this, what would be the distance for that? Distance, the length of an arc. Now imagine adding up each little bit here. That would be, so adding up each little bit of distance here. And it's what this is right here, this bottom left. It's the distance formula. It's got the delta y and delta x, and you're adding up each little infinitesimally small distance across that. That's what this equation is right here. Okay, they use S for arc length. Sometimes they use L. I use L usually, but I think the book uses S. That's why I used S here. But this is the formula you need for arc length. Now, if you're wondering where the heck did this thing come from, you don't need to really know where it comes from, but I'm going to show you for fun. So the red here, it's the sum of n points. That's what this is. Each infinitesimally many points from K to N here. So this is summing up the distance. Again, you don't need to know this, but I know Lath's probably interested. If you're summing up this distance here, the distance formula is right here. That's what this is, distance formula in orange. If you have N go to infinity, so you have infinitely many of the points for the sum, you end up with all those delta x's and delta y's become dy and dx. And then what you can do is factor out a dx here, dx squared, I'm sorry. The square root of dx squared shows up right here. So I took that out. So this becomes a 1. dy over dx is the derivative squared. So that's why it's the derivative squared plus 1. So it's all this work just to get to this awesome, fancy little equation here for arc length from A to B. Again, whatever the interval is, the A to B. So that's basically a sneak preview of everything we're covering, and it's all based on adding up little bits of something, whether it's little bits of distances, whether it's adding up areas of certain shapes along a certain interval, rotating an area around an axis. This one you're taking the actual integral, the area, and dividing it by b minus a, which is the interval here, to figure out the average value of each of these infinitesimally small little y's here. And then 511 is, I mean, it's just the same thing as the regular area. You're just subtracting off an area on the bottom. Are there any questions, just general questions on any of this stuff before we go a deep dive into this? No questions. All right. Let's whiteboard this up here. All right. So this is basically everything we're going to go over today: 511, 512, 514. And then here are those practice final problems. If you remember where the practice final is, everything's on the Math 132 homepage. So if you go to this, practice final exams right here with the solution guide for each of the problems as we go. So if you look for the solutions to these problems, they're not there yet. But we did all these other ones already, but we are on these right here. Hold on 1 second. Let's refresh this page. The formatting got all weird for some reason. And if you notice also, I got rid of, for 514, I got rid of arc length for polar and parametric, just because I figured people are done with those, with the parametric and polar. Let's just stick to regular old functions here. But we're going to be doing, and I just screenshotted these. So these are the exact same problems that were in the whiteboard here. And we're going to, again, if you want to stay after class, after this lecture, then we're going to go over those and you can ask questions. So that's what that is there.
There's a question in the chat.
Oh, yeah, you're in charge of that, Lath, if there's ever a question, because I didn't hear it. Are we going to do work energy problems too? I was, yeah, I kind of got rid of those. Do you want to go over those? Okay, how about this? If you want to go do the work, okay, done. There you go. You convinced me. There was another thing with work, and you're basically, with work, you're adding up the forces throughout a distance. It's the same thing as adding up areas. So why don't we just stick with the areas and make it simpler? So thank you, Kelsey. Notes taken on that. And then, yeah, if anyone can, because I don't actually see this, and sometimes I'm talking, I don't actually hear the little beep thing. So yeah, Lath, if you want to be in charge of that, or anybody, I'd appreciate it. I don't want to like skip someone's questions because I'm babbling.
We got you.
There you go. Yeah, I think I originally had work in there, but then I was like, this is it's just redundant. Why do an extra problem? That's no fun. All right, so let's go with 511. All right, let's break this down a little bit more. make sure you write down this equation. You don't really have to draw the example if you don't want. Completely up to you. This is going to be all calculator as well, so your calculator is going to help a lot, so make sure you have that out. All right, the way this works is, let's see here. Let's use a highlighter. We're trying to figure out this area right here that's already colored. So I don't know why I'm coloring it again, but we're trying to figure out that area right there. Essentially what you're doing is you're taking the area of underneath F. So here's F right here. Imagine taking this whole area, and then you're subtracting off from A to B, the area from A to B. And you're basically just subtracting off this area down here. So this is going to be all gone. That's the area of G. That's why it's F minus G. That's why it's set up this way. And it's always going to be the one that's furthest from the x-axis, which we kind of talked about before. So if you notice in the interval from A to B, the thing that's furthest from the x-axis is F. So F is first. And then the one on the bottom is G, so you're subtracting that off. And since you're subtracting off this blue area, you're only getting this part right here. It's kind of like, you probably remember those problems in geometry where it's like, this is drawn so poorly, but it's like, it'll have like a circle, which I shouldn't have chosen a circle because it's going to be a bad circle, but it's like, find the area of this part where you like subtract off the area. That's basically what this is, only with functions. Sorry, that's a very bad drawing. But hopefully that makes sense. Are there any questions on this equation? So I should check. Cool. So it's basically the same thing you were doing before, only you're subtracting off. And there's one little extra curveball that you can have, and I'll show you that with an example. But let's do this semi-easier example first. So here's an example. You have y equals secant squared x and y equals sine. What is the area between from the interval from 0 to pi over 4? Okay, if you're one of those people that love steps, step one would be to get a visual of what this looks like. Okay, visual definitely helps. You can figure out what's the f and what's the g for the formula, but you're going to need to graph it. So open up your graphing calculator. Make sure you're in, let's get rid of all that. Make sure you are in function mode. So hit mode and make sure you're in function, not parametric or polar, because sometimes people are still in polar for whatever reason. Because the last quiz, the last problem we did was polar, so maybe that's why. I don't know. I'm going to try to go slow on this, but if you're not following along, just tell me to slow down, or I can go over it again. Just right, step one, hit y equals. I'll show my key histories down here. Jeez. So hit y equals. Here, let's do this, and then we'll start over. Y equals. Okay, so hit y equals. It says the button down here to press. Okay, let's get rid of these because this is the practice final problems that we're going to do later. And then we're going to put both of the functions in there. Okay, there is no secant button, so you're going to have to do 1 over cosine x squared, which is secant squared x. And the other one is sine x. Okay, now don't graph it yet. Okay, well, you can, but don't. Hit window, and what we're going to do is we're going to change the x min and x max to match what this is right here. Okay, we're going 0 to pi over 4, so we're going to change this to 0 and then pi over 4. Okay, now what we can do is hit zoom and then go to zoom 0, which is zoom fit. I'm just going to hit zoom 0 because it takes me forever to like, oh, actually it's going, nope, it just lags sometimes. You zoom 0, and what it does is it fits it nicely to the screen. You'll see. This takes a little bit for me. Yours might be done graphing already. Also, if you are following along, hopefully you are, your graph should look like mine. If it doesn't, then you're probably not in radians. Okay? So your mode, you should be in radians. Everything in this class is in radians. So you have to, like all the derivative formulas, everything we covered is in radians. You have to be in radians. Physics sometimes is in degrees for some stupid reason, but you should be in radians. Okay, so we have something like this. Now, essentially what we're doing is we are finding this area right here between these two. So we're finding this area right here. So what we can do is find the area underneath blue, which is going to be all of this, all of this here, and then we're subtracting off the red. So the red goes away. Now you just have that area. Okay. So based on this graph, which again your calculator is going to help you with, which would be the F and which would be the G? Does anybody want to chime in?
F would be secant squared and G would be sine.
Boom. All right. So that's what I'm going to do first. This is our F and this is our G. How do we know that? Because the F is on top and the G is on the bottom. Okay. Let's color code this. I don't know. Sorry, that bothers me. All right. So let's set up the equation now. So that means the area between, let's be lazy, is from 0 to pi over 4. The A and the B are given right here, of secant squared x minus sine x dx. Okay. Now let's make sure everyone's still on board here. Are we good? Is there any questions on what I've done so far? Okay, so what I'm going to do next is I am going to do this on my calculator first. I'm just kind of like that. I'm going to put this whole thing in my calculator. So follow along. We'll do a little review for this. What's cool too is if you have this as y1 and y2, we can use the y1 and y2 rather than writing that all over again. So I'll show you what I mean. All right, so hit math 9, and we're going from 0 to pi over 4. And we want to do y1 because that's our f. This was our y1 and that's our f. So what you can do, check this little shortcut out. You can do alpha trace and then just hit y1 minus alpha trace y2. Okay, now we don't have to write all that stuff out over again, which is nice. And then you just hit enter on that and it spits out that value. Does anybody recognize that irrational number? By chance? It's okay if you don't, but it's the square root of 2 over 2. So our answer, the exact answer should be this. Okay, you can't write this down as your answer on a quiz and get full credit, but you could get some credit. So if you don't know what you're doing, then at least do this on the calculator. Otherwise, we have to somehow find root 2 over 2 because that's the exact. This, if you this goes on forever, so it's not exact, right? If you rounded it off, it would not be exact. This is exact. So let's try to do it where we get root 2 over 2 is the answer. Well, first of all, is there any questions on the calculator part? All right. Oh.
Sorry, but could you do that, how you got the y1 minus the y2 in there again?
For sure. And by the way, if you do want, you can write the 1 over cosine squared if you want, but that's like a nightmare. So what you do is you just hit alpha trace, and that brings this thing up. Unless you have an older calculator. If you have an older calculator, you're not really going to be able to do that. Actually, if anyone has an older calculator, like an 83, I believe, doesn't do this, I'm going to show you a shortcut. First of all, does that answer your question, Sean? Are you good with that? Alpha trace?
Yep, thanks.
Okay. Sometimes I talk fast. I just don't want to. All right. So what you can do if you have an older calculator, you can hit vars or vars because it's variables, and then you can go to you hit the vars button and then go to this y vars, so arrow over, and then click function, and then it's got all the y sub 1, y sub 2, yada yada. So you could still, have that there. Or you can just rewrite it. Some people like to rewrite it. Okay, but we know we should get root 2 over 2. Oops, wrong one. All right, so let's do this. All right, math's a language. Let's translate this. This means take the antiderivative, plug in this, and subtract those. So that's what we need to do. Take the antiderivative with respect to x, plug in this for each of these, and subtract. So that's what we're going to do. First thing we're going to do is do the antiderivative. Now, this is semi-tricky, and if this ever happens on a quiz and you're like, oh, shoot, I don't know the antiderivative of secant squared. Well, just think, what the derivative of what is secant squared? Does anybody know?
Tangent.
Tangent, thank you. So tan x is, the derivative of tan x is secant squared. So the antiderivative of secant squared is tan x. if you don't know that, again, on a quiz, just ask me, because I don't expect you to memorize everything all the time. So when in doubt, ask. The worst thing I'll say is you should know that already. Okay. Sometimes I let you just ask the whole class. I'm like, well, does anybody know this? And then Lath could shout it out and help everybody out. I think that happened the last quiz. Some people were leaving early, but this one person asked a question and then it helped out other people. So it definitely helps to do that. All right, now we have to do the antiderivative of sine x. What's that? Anybody?
Cosine.
Negative cosine.
Negative, sorry.
Because, okay, you already did the plus. Okay.
Yeah.
Yeah, the antiderivative of sine x is negative cosine x, but the minus makes it positive. Sorry, yes, you were right. Boom, boom. All right. Now we're integrating it from pi over 4 to 0. So remember, you do the antiderivative. Cool, we have the antiderivative right here. Now you plug in pi over 4 to both of these. Then you plug in 0, and you subtract those two things. So let's do that now. So we're going to do tangent of pi over 4 plus cosine of pi over 4. Okay, that's the first part. Minus, I'm running out of room, sorry. Tangent of 0 plus cosine of 0. And then just give me 1 second here. Cool. All right. Now you might go, well, I don't know what tangent of pi over 4 is. Check in your calculator first if you really forgot. But you're supposed to know the unit circle technically for this class. Oh, it's 1. Cool. Okay. So it's equal to 1 plus cosine of pi over 4. Again, say you forgot that. Just throw it in your calculator. You should recognize this one by now. That's root 2 over 2. Remember from before. So that's the first part. So this is 1. This was root 2 over 2. Okay, tangent of 0 is 0. If you don't believe me, you can just check that. So this is 0. Cosine of 0 is 1. Oops, that's a plus. That's embarrassing. Okay, and then check this out. 1 minus 1 cancels. The 0 is gone. So you end up with root 2 over 2 as your final answer. And if you remember, the calculator said that we were supposed to get that. So, pardon the noise, I'm sorry. And then we have the answer. All right, questions on that first one. I tried to show it visually. I tried to show it with a calculator, like doing the work, and then actually going through and doing the step-by-step work. So, questions on that? Is there a certain color that's confusing? I guess I should check the chat. Nobody. Awesome. And hopefully no one has questions. All right, so that's the first one. Now, if you notice, this one has 2 examples. The reason why is because this can semi be a curveball a little bit, depending on your math understanding. This one, if you notice, what is this one missing that the other one, had? This problem right here.
The limits.
Yeah, the limits of integration, the intervals of integration. How do we know the A and the B for the equation?
Set them equal to each other and find where they intersect.
Right. So what she's saying is we're missing this part right here. Okay. So that's what that is. We need to figure that out. So we need to figure out the A and B, and yes, awesome that you have to set them equal to each other, but there's also another curveball in setting them equal to each other. And then if anyone wants to chime in on why this is a curveball for solving. Anybody? I mean, it is tricky.
You need to use a calculator to find the X, right?
Why do you need to use a calculator? You are right, but why?
You can't physically solve it.
Right. You can't isolate X is what he's trying. Yeah, you can't solve this. Like, if you could figure out a way of solving this, then let me know, because we're going to be famous then. But you can't actually solve for X here. but your calculator can figure out an approximation. What your calculator is basically going to do when we solve this is it's going to guess and check every number within a certain range. Does 0 work? No, 0 doesn't work. Does 0.01 work? Does it just keeps going closer and closer to figure out where these are actually equal. It doesn't iterate through each possible interval. We don't need to worry about it. We're actually going to talk about how the calculator works in solving this later. But the only way to solve this, to find an estimate of what the solution would be, is to use your calculator. So that's what we are going to do. We are going to graph the first one and graph the second one, which we should do anyway, because that was the first step before, was to figure out what we're doing, like get a visual of what we're looking at. So we need to figure this out. So let's go back to our calculator. Okay, this is very important because it's probably going to be a problem like this on your quiz. Hint, hint. Okay, your y equals. Set that equal to the one side, the first y of this, 2 cosine x. And then we're going to set the other one to the x squared minus 1. Okay. Now, if you remember before, I went to my window and changed it to 0 to pi over 4. You don't want to make it 0 to pi over 4 because it doesn't graph everything. Okay, you don't get a full outlook of like what this is supposed to look like. So every time I give you one of these where you have to graph it, just be in zoom standard. So hit zoom 6. Zoom 6 is your friend. It just resets the zoom for it. So now we can get a better idea. We can get a visual of the area that we are looking for. Okay, it's the area bounded by those two graphs. Okay, and you can see it's this weird looking shape. I don't know what you would want to call that, but let me just screenshot it. Go back here. Let's blow this up just a little bit. I don't want to run out of room. But basically what we're doing is we're trying to figure out what is this area here. Okay. But to do that, we need to figure out, like, I think it was Kelsey. I'm sorry, I don't know people's voices yet. Who was it? Who said that before? Hello?
Yeah, that was me.
Oh, okay, cool. Thank you. So we need to figure out what is this x value and what is this x value. It is symmetrical, so if you pick one, it's usually just the opposite sign for the other one. But I'm gonna show you how to find this with your calculator. You probably know how to do it from algebra, but just in case you forgot, I'm going to show you how to solve this using the graph. So what we're going to do is second calc. 5 is your intersect, so we're going to hit 5. Okay. First curve is my first y, which is the blue. So I'm going to hit enter. I want that one. The second curve is the red, which is what we want. Okay. Now the guess. When it says guess, it's poorly worded. I don't know why it says guess, but you really want to be closer to the intersection that you want. Okay. So we need to be closer to this intersect. I always go to right. So I'm going to find this intersection point first and then this one next. So I'm going to move that cursor over when it says guess and then just hit enter. And then it finds that value right there. 1.265424 negative. Okay. So that means one of the solutions to this is negative 1.265424. Lath. Is that right?
Yes,
okay.
That is right. Yep.
All right, cool. Thanks. Again, if anyone's wondering why I pick on Lath, he was my student in high school. Like I had him, so I'm not just being mean to him. He's cool. All right, so this other one, we're going to do the same thing. So I'm going to repeat the steps. Second, calc 5. Okay, blue, enter. Red, enter. If you have a color calculator, this obviously makes it a lot easier. And then it says guess. This is closer to this intersection, so we don't want that. We're going to go to this one over here. Whoops. It doesn't matter if you overpass it. Just hit enter, and then it finds it right here. Same thing. And if you notice, it gives you an extra digit this time is because there's no negative.
Don't forget to store it.
Well, oh, yeah. Yeah, that's right. I didn't show that first section in the first class. I should do that, though. All right, let's quit out of this. What you can do is if you quit out of that, wherever that last x was, it'll store that value, and you get even more decimal places. You usually don't need that many, though. Like use as many as you can, though, because sometimes it throws rounding errors off. But if you want more digits, you can do that. What he's talking about is storing, but I feel like that's going to be crazy to. Well, I'll just show you how to do it. This might get a little technical. If you're a computer science person, you'll probably love this because it's about variables. But anyway, what we're going to do is we want this to be in this case, it's our B. So you can hit this STO button right here. It stands for store. It's storing this answer, and then you can hit alpha B. And now your B is that. So now if ever you want to use B, you don't have to rewrite the whole thing. It just spits it out. So it abstracts away all those numbers. Okay. Now negative B, we want it to be our A. So I'm going to store that in for A. Okay. Hopefully that's not too complicated to do. So you can do that. So now what we're going to do, first of all, let me go back to my work really quick. And if you do not want to do the store thing, you can just write all the digits out if you want. Okay. And then I'm gonna actually label this. This is equal to A and this is equal to B, just because I don't feel like writing this ever again. Okay. So what I'm going to do now is say the area is equal to A to B, which is right there. You can write it all in there, but it's a nightmare. So why would you want to do that? Okay. So we're setting up that formula from before, the F minus G. Okay. In this case, our F is 2 cosine. Now, the reason you know it's the 2 cosine is because it's the blue, and the blue's on top for this interval. Or I'm sorry, it's further away from the x-axis than the other one. All right, so I'm going to say 2 cosine x minus the one that's on the bottom here, dx. Now, if you flip-flop these, just know that your area can never be negative. So if you ever flip-flop these, the F and the G, you're going to get a negative area. Just make it positive. I'll give you full credit. Just as long as you don't have a negative area, I'm happy. Okay? Don't rewrite. Oh, man, I messed up the F and the G. I got negative. I'm going to erase it and rewrite. Don't do that. Just make it positive at the end. Save yourself some time. Okay? Now, you might be going, how am I, like, if these values are both in my calculator, how am I going to like throw these in here? You're going to end up, long story short, you're going to end up using your calculator anyway for this. So what I'm going to do, anytime that you have a problem where you have to figure out the intersection points using the calculator, all you have to do is use your calculator to solve this. You don't even do it by hand. You're welcome. So all you have to do is go back to your calculator to solve this. So clear this out. I'm going to go math 9. Whoops. Math 9. Now, rather than putting that 1.265424 thing in there, or negative in this case, I'm just going to put in A. The calculator knows what A is, because I told it what A was. Then I'm going to put B. I don't have to rewrite it. Now, if you want, who cares? It's just a bunch of buttons. But I teach my students in high school, like you're more prone to error if you type the wrong button in. Where B and A, you're probably not going to mess up writing B and A. But you might say 4524 instead of 5424. You might mess up the order, throws off the answer. You end up getting it wrong for something silly. Okay, so that's why I would use A and B. You don't have to, though. It doesn't really matter. Okay, then you just have to put in 2 cosine x minus, parentheses, x squared minus 1 with respect to x. Boom, hit enter, and you get your answer. Okay, in this class, you always round to 3 decimal places. Okay, if you ever forget that, just ask. You round to 3 decimal places. So you should have that 4.995. There's your final answer. Holy cow, that was involved, huh? Let's do this. Okay. Questions on number 2 here. Well, actually, you know what we're going to do? Let's take a 5-minute break. And if you have questions, I'm just going to be sitting here. If you need help with your calculator, if you need help with whatever, just let me know and I'll help you. Okay? 5-minute break. Set timer for 5 minutes.
Okay, 5 minutes and counting.
Cool. Anyone see the Apple keynote?
Oh yeah, I saw it.
iOS 14 looks pretty cool. Like I love changes.
I'm
You
kind of
know,
disappointed for the Mac OS though.
Why? What's
It
wrong?
wasn't.
Oh, because
I
there's
don't
no
know.
big changes. Oh,
Yeah, it was.
you have a MacBook Pro or whatever, right?
Yeah, it. I was wondering if it could like make it much more like I don't know. It's more like video editing style. I don't know. I don't like it that much. Yeah, I want it to be like more like intensive coding style, But
Yeah, I mean it was marginal. I felt like iOS 14 was the big change, but
yeah, yes. Opening the car with your freaking phone, that's crazy.
the
But it's only with
that BMW model or whatever.
how much is
The
that?
did you I wonder how expensive their computers are going to be since they're making their own processors. Are they going to like overcharge say that they're better processors or something like that? So
Yeah,
I
because
wonder
they use
how,
Intel.
yeah, but I remember it was a big deal when they went to Intel to begin with, and now that they're going
True.
back. It's going to be interesting. But I hope it's cheaper because I wouldn't mind buying another Mac, but at the same time, they're just so friggin' expensive.
True, no,
compared to what you get, like it's not even worth it.
Yeah, no.
In my opinion, somebody's probably offended.
You can get a better like built computer way cheaper than a $10,000 MacBook. Because it's like you can use the i9, I think, but it just caps it off way on like $2,000 extra dollars. It's crazy.
Oh yeah, if you up the processor speed, it just goes crazy. Yeah, it's insane. This is an i7, but I upgraded it a ton. Like
oh yeah, I have an i5.
Yeah, I'm on an iMac right now, but it's I upgraded it a bunch. Like obviously I didn't upgrade it. Like you have to have Apple do it because you're not allowed to open these things up. Dude, have you ever tried to open up an Apple computer or even an iPhone?
Yeah.
Dude, they have like, hold on, I just bought the MacBook Pro with an i9. Nice. Yeah, how much was it? Kelsey.
Probably.
Yeah. I don't even want to know. At least
15. There's always like people who want to. Like,
oh my gosh! Oh
Oh geez. Okay.
Wow.
Flexing too much here.
Yeah. How big is it? What's the monitor? How big is the screen? Oops, that's done.
Ooh.
Yeah, but if you try to take them apart, like there's engineers that. Oh, nice. 16.
16. That's nice.
There's engineers that made it so you can't reverse engineer. You can't take them apart. Like the amount of like they did extra work so you couldn't take it apart. It's just like it's kind of like sickening. It makes me never want to buy Apple.
Yeah, that's why I don't like Apple and stuff. But I'm excited for the PS5 though. That's the thing. Yeah. For 2020.
I'm not into that gaming stuff. I play on my game on my phone.
Yeah, I mean I have my PC as well, but I don't know.
All right, back to math. Here we go. All right. So 512 is average value of a function. And the way I look at this every time is kind of like what I said before. There's all these individual little spots, all these y values, just infinitely many of them across here. And if you add up all those y values, whatever they are, remember the y-axis is right here. So whatever those y values are, and then you divide by b minus a, you get the average. This, what I drew out here is as a proof for it, but it's using the area of a rectangle. All right, so if you took the area of this thing right here, where the height is the average value, and it's just arbitrary. We don't know what the average value is, but say this height from here to here is the average value, and the bottom part here is b minus a. The area of this rectangle that I just drew here, the one in this cyan color, is base times height, which is the average value times b minus a. Now, we want that to be equal to the area underneath f of x. So that's what this is right here, the area underneath f of x. Well, if you want to find the average value, just divide by b minus a, and then you get the final formula right here. You don't need to know any of that. I just think it's cool because it's a little cool proof using basic geometry to figure out what that is. So the area of a rectangle is equal to the area under f. For this rectangle, that has to be the average value for it in order for that to be true. And you get your formula. Again, you don't need to worry about that, but you do need to worry about this, how to use it. Now, it's the exact same thing we've already done. We've always done this top part. We just never did the bottom part. So the extra step for average value is you have to divide by b minus a. Okay. Another way of looking at this is imagine you had a lineup of people that are standing shoulder to shoulder. Here, let me get rid of this. Oops, I didn't want to do that. They're standing shoulder to shoulder, and those people are infinitely thin. So just imagine like a bunch of people that are standing next to each other like this, but they're infinitely many. So they're filling in all these spots. If you average all their heights up, you can add up all their heights and divide by b minus a, and that would show you the average height. That's what the average value of a function is. It's just really the average y value. Okay. So that's what we're going to use for this one. Now, if you notice, there's only one example here. I don't do another example because I did 2 examples for this one because there's a trick. This one, there's not really a trick. It's just following the formula. Okay. So do the integral from a to b and then divide by b minus a. So that's what we're going to do here. So what is the average value for this function on this interval? So let's first set up the equation. And it's equal to the integral from 0 to 3 of f of x, which is negative x squared over 2, dx. And then you're going to divide it all by 3 minus 0. If that was a 1, you divide it by 3 minus 1. Okay. First thing I'm going to do here is take out this negative 1/2. So it's technically a negative 1 over 2 here. So I'm going to take that out because it's a constant multiple. I'm going to take out this divided by 3 here. So I'm just going to do 1 divided by 3. And then I'm going to do the integral from 0 to 3 of the only thing that's left in there is x squared dx. Okay. You don't have to do it this way. If you want to do it your own way, that's fine. I just like putting all the constant multiples out in front. And then it's just like, oh, cool, I'm doing the antiderivative of x squared. Remember, math's a language. We're doing the antiderivative. Then you plug in 3, you plug in 0, and you subtract. That's what this means with respect to x. So we're going to end up with negative 1/6. Oops, I didn't get a visual first. Oh, how dare me. Let's graph this. Okay, ready? Negative x squared over 2. Okay, now we are in an interval, so I'm going to change the window from 0 to 3 and then zoom fit, so zoom 0. By the way, if you ever forget how to do something on your calculator, ask me during a quiz, I will tell you. I don't mind helping with the technology piece of it. Okay, so now, if you notice, we're going 0 to 3. The x-axis is up here. Here, let's do this. Okay, so the x-axis up here, it's let's do this color. It's this right here, and this is the y-axis right here. Okay, we were trying to figure out the average value. If you notice, they're all going to be negative of this right here because it's between the function and the x-axis. So we're looking for this area, and then we're going to divide by the 3 minus 0. So you're looking for the average y value here, and if you look at it, you've got a visual of it, you should notice it's going to be negative because the integral is negative. Okay? That's part of the reason why there's a negative right here with a negative 1/6. Okay? So that's just a visual to understand what we're doing. Okay? And we're doing the integral, the antiderivative of x squared. So you're going to add 1 to the power, and then you're going to divide by that power. And we're integrating it from 0 to 3. Okay. I'm going to pull that 1/3 out, so it's negative 1/18. And you plug the 3 in, you get 27 over 3 is 9. Minus, you plug in 0, you get 0. And you end up with negative 9 over 18, which is negative 1/2. Okay, let's make sure that this is right. So we're going to go back to our calculator.
Didn't you already pull out that 1/3?
Yeah, see, I should have picked a better example. Technically speaking, this 1/3 right here is from the antiderivative. This 1/3 is from the division by b minus a. It's a different 1/3.
I guess I'm confused then how you went from negative 1/6 to negative 1/18.
The negative 1/16 was from this part right here. Hold on. Did I do something wrong? Anybody else? I always assume I'm wrong. I might have just messed something up. Okay.
I don't think so.
Okay, this is negative 1/6 from this divided by 3 right here. And this 1/2 I pulled out, and then divided by 3 I pulled out. I didn't do the antiderivative yet. So when I add 1 to the power, you get a 3 here, and you're dividing by 3. The 1/6 is separate. So the 1/6 is from this thing here. Go ahead, sorry.
No, I guess I'm also confused with how you went from 1/6 to negative 1/18. Like if
All
you
right.
do, I guess, yeah. Sorry.
Oh, no, don't be sorry. This is, hold on, let's, oh, did I do something wrong here? All right, let's restart everything here.
Yeah, you pulled out the 1/3 and then still continued to divide the 27 by 3
Yeah.
after you pulled out the 1/3.
Oh, that's embarrassing. Okay. So never mind. Yeah, this 9 is wrong, but the 1/6 is right and the 1/18 is right. Yeah, I figured I was doing something wrong. All right, so this 1/6 right here comes from this divided by 3 and this divided by 2. Okay, this divided by 2 is the same as multiplied by 1/2. This divided by 3 is the same as multiplied by 1/3. And then multiply by the negative, so the negative's there. That's where this comes from. This divided by 3 comes from the fact that we have to do reverse power rule. So you add 1 to the power and then you divide by that power when you do the antiderivative. So that's a different divided by 3. Was that Sean that asked the question?
Yeah.
Yeah. Okay. Does that make sense where that 3 came from then?
No, I understood that part. It was the
extra division by 3?
It was the 9 there that I guess.
Okay. So yeah, that should be 27.
Yeah.
I'm sorry.
Yeah.
I'm sorry. Well, thanks for calling me out on that. I appreciate that. Definitely don't want to, because if I'm confused, it means other people are going to be confused too. Okay. So then now you have 27 over 18. Both negative 27 over 18, I'm sorry. Now, both of those are divisible by 9, so you end up with 3 over 2. So you should get negative 3. Is that right? Let me check out my calculator. Now I'm second guessing myself. Oh, man. Too much fun. That should be right. Kelsey, is that right?
Maybe. I didn't really
Okay.
check.
Well, we will check right now with a calculator to make sure. I was just asking you to save some time. So let's check with our calculator. Sean, are you feeling better about this?
Yeah.
I
Thanks.
got
All
the same thing.
All right, so let's do this entire thing in the calculator here. So now we're going to do, okay, so someone got the exact same thing. I don't know who that voice was. I'm sorry, but thank you. All right, so we're going to do, now this, remember our Y1, did we even, yeah, we did put the Y1 in there. Okay, so we're going to use the, oh, shoot, I hate how it does this. It always defaults to move it all the way over. All right, we're going to do alpha trace. Oh. Hold on. My cursor, it defaults to all the way to the right every time on this. There we go. Okay, alpha trace Y1. Okay, with respect to X, and then we're dividing by that 3 minus 0. You don't obviously need to put the 0 in there, but I like to put it in there because some people think it's always just whatever the first number is. Like if this was a 1, you'd have to put a 1 in there, obviously. And you end up with negative 1.5. Thank goodness. There we go. I ask people's names because I try to make mental notes of that. And then later on when their grade is like in between like an A and a B, I'm like, oh, you know what? Sean was awesome and he helped me out. I'm bumping his grade up. So that's why if you ever wonder, why does he always ask names? I don't get it. That's what that is. Because you're helping me out. Plus it means you're paying attention. And if you're helping me out, then you obviously know the stuff. So I love it.
So if we're really being a pain in the butt, we should lie about who we are. Is that all clear?
Yes.
So,
And then always use lathe as the fallback
right.
for that.
Okay. Okay,
Yeah,
cool.
I'm kidding. Okay, so anyway, that's the problem. That's literally all there is. And I'm going to show you the practice final problem that's related to this as well. It's over here. As you can see, it's just 4 minus x squared. I went to 0 to 3 again. That's annoying. But 3 is my favorite number. I don't know why I picked 0 on this, but I should have done 1 or something. It doesn't matter. There's so many practice problems where it is different intervals. than 0 and 3. And then you can even see up here for area between, you can see it's just, I don't give you the interval. You have to figure it out. But again, you can figure it out using your calculator. So if you don't like solving quadratics, excuse me. And then the last one's arc length, but we're not there yet. Also, I kind of explained this before. When it's a double star, that means you might have covered it if you took calc anywhere else besides Wabanzi, or didn't cover it. Arc length is usually covered in calc 2, but this is covered in calc 1, and this is covered in calc 1. Not Wabanzi's calc 1, other people's. I say usually, meaning more than 50% of the time. I don't know the exact percentage for that. But so if you've seen 511 and 512, I'm sorry to bore you. 514 should be new. Lath, have you seen 514?
No, I haven't. I'm excited.
All right, cool. You're excited, of course you are. All right. Hold on 1 second. What did I do? Oh no, I moved something. I didn't want to do that. Things got cut off. It doesn't matter. This is all we need. All right, so hold on, I can do this. That makes it better. Makes it better a little bit. Hold on 1 second. I'm gonna save as really quick. I just don't want to lose the other thing because this got cut off. All right, so next thing is 514. Or wait, does anyone need a break? We only really did one problem. But if someone needs a break, by all means. Did anyone message? Fun stuff. Specs looks so good. Yeah, we're going to have to talk about that. All right, cool. We'll go to this then. Okay, arc length, it's just one kind of problem as well. So there's only one example. There's not really anything tricky with it. Again, with arc length, just to kind of review what we already semi-talked about, but now I can write on the screen, is you're adding up all the little mini distances for each one of these throughout this whole thing. Infinitesimally small distances. Kind of showed that picture already, but that's what this is saying right here. Add up the distances. If you want infinitely many of them, now it turns into an integral. Factor out a dx quantity squared, and the square root of dx quantity squared ends up being this thing right here. So that becomes a 1 when you factor it out. When you divide out the dx here, it becomes the derivative, which is nice because then it's easier to find. And then you end up with this formula right here. Quiet down there, sir. It's okay. I was just kidding. All right. So, okay. So here we're looking for the arc length. Again, first thing I want to do is figure out a visual on this. So let's graph it. Y equals. All right. So we got sine x. Now we're going 0 to 2 pi. So just go window 0 to 2 pi. And then zoom 0 fits it to the screen. Zoom 0. So there we go. Okay, pasting this in here. Let's blow it up a little bit. Okay, so what we are looking for is we're trying to figure out if you walked this path, what would be the distance of the path that you walk? Okay, before we even do anything, let's just do a little bit of thinking here. We know that this arc length from 0 to 2 pi has to be limited to what value, essentially? It has to be greater than what value? Just by looking at this. Does anybody know? Here's a hint.
Greater than 2 pi.
Thank you. This needs to be greater than 2 pi. Okay, we know that for sure because this is 2 pi. Okay, if you were driving or running or walking or just going from point A to point B here, you would want to just do a straight shot. I mean, maybe you would want to. I guess it depends on your goals. But this is a longer distance than 2 pi, right? Because it's out of the way each time. So it should be greater than 2 pi. So if you get an answer that's less than 2 pi, you know you did something wrong. First of all, does anybody want to guesstimate what this is? So 2 pi is 6.28. Let's just say. So is this going to be around 7, 8? What do you think? Anybody? I really don't actually know the answer. So Does anybody want to guess? Is it twice the distance?
8.
4 pi. All right, 8. What else? Any other guesses? It doesn't matter. I'm just trying to have fun here. This is how I have fun, apparently. All right, so let's do we're looking for the arc length here. Now, to do the arc length for this, you need the derivative. So what I like to do is find the derivative first and square it, okay? That's usually step 1. You could throw it into the equation, but then you're writing more stuff out. I like to parse it out a bit more. So we are going to find the derivative of y with respect to x, and you get cosine x. Okay, then I like to square it. So now it's cosine squared x. Okay, now I can set up my formula, and I know that I'm going from 0 to 2 pi, and it's going to be 1 plus cosine squared x dx. Okay, this is me setting up the formula completely. Okay, now what integration technique do I need to use to figure out this antiderivative? Does anybody know? Any takers?
It wouldn't be U sub because
Right, U sub would definitely not work. Very good. What else?
just use it by the power rule, right? Or no?
That wouldn't work because you have a composite function.
Mhm.
Power rule only works if you have just a power, not a power inside of a power kind of a thing. It works if it's x squared, x cubed, x to the 7th, but that's not what we have here.
Oh, we get to use the formula we had for cosine squared, right? Or no?
Oh, actually, okay, pause. Don't do that because it doesn't work.
Oh.
I just want to save time. I don't want to get anyone mad. This is actually a trick question. There is no integration technique that we've covered that does this. I was seeing if anyone would actually say there isn't one. You can't do U sub, and it's a composite function. And if you can't do U sub for a composite function, which you normally would use, then you kind of know that you can't do anything because it's not integration by parts. Let's see, that would be, let me try it. No, yeah, integration by parts wouldn't work. Because you would go in a circle. If you did, say this was your u, if you did the derivative of it, you would still have another square root. You would have a more complicated function. Integration by parts works if one of the parts actually simplifies. For example, if I had something like the quiz we had where it was like this, like the x derivative simplifies to 1, so now it's simpler. There's nothing here that simplifies. If you try to do the derivative of this whole thing, you end up with this. Don't write this down because this is a nightmare. Times 2 cosine x sine x. And I probably made a mistake. Okay, that's definitely not simpler. That's a nightmare. So don't, long story short, you can't do it. So the only time you actually can do one of these problems is if they're completely contrived where the derivative or whatever the derivative squared plus 1 is a perfect square. If this was a perfect square, then you would do the square root of it, and then you would get to be able to do an answer. But 9 times out of 10, you have to use your calculator on this. So this thing can only be found right here using your calculator, long story short. Okay, so let's just make an executive decision right here. You're going to use your calculator on arc length problems, okay? You don't have to worry about doing any antiderivatives, okay? Now, if you do the practice problems, you're going to see some where they're contrived problems and they come out to be perfect squares, and it's so amazing. But like that only works, again, if this inner part is a perfect square, and it's just, that doesn't happen. Especially since when you square something and then you add 1 to it, it's usually not a perfect square. But if you squared this, that's a perfect square, but now it's not because I added 1. Do you know what I mean? No, it doesn't matter. I'm sorry, I'm talking too much. Long story short, let's use our calculator. Here we go. Get out of this, okay? Clear, math, 9, 0 to, whoops, that's, well, you can do pi 2, it doesn't matter. Oh, that's not what I wanted. Okay. Oh, I did it again. 2 pi, okay. And then it's the square roots of 1 plus cosine x squared. Bye, Mom. 1 plus cosine. Let me just, sorry, I got distracted. All right, and then hit enter. And, Lathe was right. I mean, it was the closest to being right. So 7.640 is roughly your answer. Round to 3 decimal places. Por favor. And there you go.
So I'm sorry if I ask this, but what does the number mean again?
What number? The number that we just found?
Yeah.
If you walked along this, the distance would be 7.640.
Okay.
Yeah. And that's basically the last example problem we're going to do. And they're all similar to that. Like if you look at the example problem right here, this one's a little bit more fun because it's an ln secant x. Actually, this one comes out to be one of those perfect square ones. But again, executive decision, just use your calculator. Okay. Any questions on any of this? Sorry, it got cut off. I got to fix that. I think that's enough. Okay. All right, let's take 5, and then we will do these example problems here. And then if there's extra time at the end, well, there is extra time at the end. If you want, you can ask questions on your quiz or whatever you want to ask questions on. Sound good? All right, let's do it. Set timer
there's
for
a
5
question.
minutes. Oh,
There's a question in
Okay.
chat.
5 minutes and counting.
let's see here. The area between curves, are we doing the problems with dx? No, because what a lot of people do is they just switch the x and the y anyway, and it ends up being the same problem. So I'm not going to try to trick people by switching x and y. It doesn't make it any harder, long story short. Kelsey. The next subsection is disk method, washer method, and then volume of cross sections.
I remember I love disk and the washer methods.
You don't like cross sections?
No, from the last unit 5, I remember when we did, we practiced a lot on the disk and washer method. I mean, I did a lot on. But I don't know. I like those more because it's weird to think. Because I like to think 3-dimensionally sometimes.
Yeah, I mean, the cross sections are still 3-dimensional though. I just like the cross sections because I feel like it's more interesting shapes than just
Shapes. Yeah.
Kelsey, does that answer your question? Wolf, I'll show you. I break it down pretty well, I feel like, anyway. They are hard, though. But we're spending a whole day on them, so. Can you call Michelle? They said our closing is the 7th instead of the 9th now.
They said what?
They said the closing is the 7th, not the 9th on the contract. Home insurance needs to know that. That's why.
So just ask Michelle what day it truly is.
Yes. Please. They said it needs to be done like soon, and I just can't do it right now. If you're busy, then don't. So Kelsey, why did you need such a powerful computer? If you don't mind me asking. Are you like a video editor or something?
No, I don't know.
I mean, that's gonna last you 10 years.
That's what I'm saying. I'm gonna be using it off when I like go to college. So I'd rather have like an investment in like a better computer because I'm gonna be basically using it for like however many years I decide to go to college for.
Yeah, and their hardware, the hardware is very, very reliable. It's like a Honda almost. Like, well, I mean, Hondas are more cheap, obviously, but like, I don't know, like the computer I'm using right now is 8 years old and it's like perfectly fine. Like, never had any issues, doesn't overheat, and it's still, it hasn't lagged down yet. But it's a Fusion drive. I have an i7 in it. It's, what else? I don't even know. But
Do you have a PC?
dude, you can see my computer in your screen. Can't you?
Oh.
It's an iMac.
Oh, it's an iMac. Oh.
I bought an iMac and I did the drop down menus and I just made everything the most possible. So the most memory, best processor, Fusion drive, just everything. It's like, forget it. I'm just gonna do it. But it's 8 years old, So it was like super expensive when I bought it, but
How much was it?
I don't remember. Probably 3.
Yeah.
Have you seen the iMac Pros or have you seen the Mac Pros? Holy cow.
I mean, to me, iMacs, it's always, to be honest, because like I know there's.
I just like the all-in-one. Like the way my desk is set up, I like the all-in-one. I don't want to tower
it's yeah, MacBook, like Apple, everything is user friendly more. Yeah. I just don't like
the one thing with the MacBook Pro is you're not as powerful as an iMac, and you're paying more for the mobileness of it. So I do a lot of video editing stuff. I would rather have, I don't know, a powerful computer that's like I have a Chromebook for my mobile, and then I have my Windows machine for work.
Nice.
So, no offense, Kelsey. I'm just talking about myself. If you have the money, then do it. All right, that's time. I could talk about this forever. I prefer AMD more honestly. Yeah, too bad you can't open up your MacBook Pro. Actually, open up laptops just in general are a nightmare. But all right, let's do some practice problems or some final exam problems. Here we go. All right, so this first one here says find the area of the region bounded by that. Okay, yeah, just get started with it. I'll slowly start doing it just like normal, and then ask questions as you got them. Okay. And we're looking for the area between. What's the first step we should probably do on this? Anybody?
Graph it.
The X values.
Yeah, get a visual. Yeah, graph it. Graphing it helps you get the X values. Even if you don't have a calculator, which you will in this class, but if for another class, if you don't have a calculator, then graph it by hand. It's not going to take too long to at least sketch this so you get an idea. So that's what I'm going to do is I'm going to graph this. All right, let me see. Whoops. Come on, Lath.
What?
You forgot it too. I'm just kidding, dude. All right, and then I don't know where the X values are, so I'm going to do zoom 6 to put them both on the same screen, get a visual of what I'm looking at here. And there you go. So we're looking for that shape right there, which looks way too similar to the other example we did. I'm sorry. Okay, so we need this value and this value. And we are looking for the area of this. Okay. Actually, I want to do a better. I'm gonna do a better screenshot here because I'm going to use this as the solution guide. So I just want to make sure people know what to do. Oh wow. Okay. I was going to say what just happened. I know. I can hear him. All right, let's find the intersection points here by doing second calc 5. If you want, you can just solve this too. This quadratic isn't that bad. Oh, jeez. All right, so the area between is equal to, we're going to 1 over here. That's x equals 1. This one is x equals -1. If you don't believe me, you can just check it. I'll just do it for fun. Second calc 5, enter, enter, and then we're going to have to move this closer to the other one. Hit enter, and then it finds -1. One thing, do not do this, okay? Because someone did this in the last class, and I know people just do this in general. They hit trace, and then they just eyeball it. They're like, okay, it looks about that, but that's not exact, okay? So don't write -9.0909. Don't do that. Actually, like, do the second calc 5 to figure out what it is. Okay. The blue one is the one on top, and that's this one here. So this is our F, and this is our G. G. Okay. Now, since we're subtracting them, I'm just going to subtract them right away to make it simpler. So I'm going to do -2x squared minus x squared. So then you're going to have -3x squared. And then I'm going to do 7 minus 4 to be 3. Okay, you can do them separate. I don't know why you would want to, though. It's a little bit easier doing it this way. Okay, keep going. I'll be right back. My son's waking up. All right, sorry about that. All right, here. Are there any questions so far with what we're doing? Okay, if you remember, this means antiderivative, plug in 1 and -1 with respect to x. So let's do this here. The antiderivative should be that. Am I on the right track? I just want to make sure I didn't mess up something silly because I just left and came back. Are we good? Is everyone okay?
Yeah, we're good.
And you should get 4. Oops, wrong one. Sorry. Okay, here we go. Let's do math 9, -1, 1, y1 minus and you end up with 4. Okay, questions on any step I did? All right, cool. All right, try the second one. Don't wait for me. All right, so I'm going to start doing the second one now. So all right, so that second one you should get 1. How are we doing? Did anyone else get 1? The
Yep.
second one. There we go. I guess I should do it on my calculator. All right, so we're going from 0 to 3 on this. It looks like there's more positive than negative, which is actually important to think about when you're doing these. Okay, for that second one, just to get some conceptual understanding of it, not that you don't have it already, but so you have this area here, and then this area here. There is more positive area than negative area, so that kind of tells you that the average value should be more positive, or should be positive, I should say, not more positive. And it is equal to 1. And an interesting thing happens when you do this. If you, that's equal to 1. If you look at the area, yeah, this is right. If you look at the area underneath this line, so that's, here, let me color it in. What's up, buddy? Yeah, hold on, dude, I'm working.
1, 2, 3.
Good boy. Jeez. The area above this line, this yellow part right here, the area up here is actually equal to the area below it. Like just the area, not the integral, not counting the fact that it's negative and positive.
He's saying he got the same area.
Yeah. He's got his counting book. He's 3. Hi, bud.
1, 2.
3, 4, 5. Good boy. Okay, we're almost done. All right, and then but anyway, that's just a fun fact. You don't really need to know that. I'm never going to be like, where's the area above and below the line? It's just how it is.
1, 2, 3, 4, 5, 6,
All right,
7.
very good. All right, let's do the last one.
3, 4, 5, 6.
You double counted that one. Left to right, left to right. 1, 2, 3, 4, 5. That's it. Don't double count.
1.
All right, how are we doing? Does anyone have any questions or anything like that?
Nope.
All right. I'm going to start working on the third one then. Did anyone get an answer for the third one? How we doing? Anyone get the same answers as me?
Yep, I did.
Well, if Lath got it, it's right. Sure then.
Oh, the buzzing.
Oh man, every time. Give me one second. Check 1, 2. Is that any better?
Yep. 10-4.
So weird. Talk about some bug. I wonder what it's time sensitive too. So I wonder what, like, some part of the code or something.
Yeah.
I don't know. It's weird. It's so weird. I should probably Google it.
Hey.
I don't know. Who knows? Oh well. Doesn't seem to be a common issue. All right. Does anybody want to go over anything else? I don't know what everyone's doing right now. Bubbles? All right. Well, if no one's got anything, we can be done then. Dog food, right?
Good class. Love it.
Wait till you see the next one. Kelsey, we'll figure out how to make cross sections easier too. Okay. I know they're complicated.
All right, Mr. Ozarka.
All right, take it easy. Email me if you got questions. Thank you, everybody. Peace out.
Peace.